All right. Hey, everybody. So I would like to do a couple more examples of finding the volume of pyramids and cones, pyramids and cones. And if you recall from the video from yesterday, the uh, volume is 1/3 capital BH, where the capital B stands for the area of the base, the area of the base. Okay. Now, as I look at my example, and again, remember, you're going to want to pause these videos, try to draw this picture, and then work it out with me. Unfortunately, the way geometry is, there's a lot of pictures and stuff, so you want to make sure you draw it. So please pause the video and draw it and so forth. All right, so this is a triangular pyramid. It is a triangular pyramid, and I know it's a triangular pyramid because I see that this base is a triangle. And furthermore, I know that it is a right triangle because of this right angle right there. Okay. Now, think about that. So that tells me my capital B is the area of that triangle, which is 1/2 base times height of that triangle. Now, that means the base and the height of the triangle, not of the pyramid, of the triangle. Now, if you look at this triangle, if I were to draw this triangle like this, right? This part is 6, this part is 8, and this part is 10. So it's given me all three sides of the triangle. But when I'm trying to find the area of a triangle, all I need is the base and the height of the triangle. And the base and the height of a triangle have to be perpendicular to each other. Well, the only two sides that are perpendicular is the 8 and the 6. So this 10 really is extra information that we will not be using for this, okay? So the 8 and the 6, that's the base and the height of the triangle. All right, so that tells me I'm going to do 1/2 6 times 8, and 1/2 of 6 is 3, and 3 times 8 is 24. So I know that the capital B, the area of the base, is 24. The height of this pyramid, remember the height of this pyramid, that's the distance from the vertex of the pyramid straight down to the base, and it's telling me right here that that is 10. So the height of this pyramid is 10. All right, I can take those values and plug it into this formula. 1/3, the capital B, we found that to be 24. And then the height of the pyramid itself is 8. All right, so if I go to that Desmos calculator, 1/3, so 1/3, I'm going to make sure I move it over so it's a fraction, times the 24, that's the area of the triangle, the area of the base, the capital B, times the 8, and that was the height of the pyramid. No, I'm sorry, 10. The height of the pyramid itself was 10. All right, look at that. 1/3, 24 times 10 is 80. All right, so the volume, oh, look at that. I messed up, guys, right here. The height, this number right here, this number right here should be here at 10. That's probably, I was doing 1/3 of 24 in my head. Anyways, this is 10. All right, 1/3 of 24 is 8. 8 times 10 is 80. Remember, we're going to use the units cubed. So the volume of this pyramid is 80 inches cubed. All right, let's try one more. Let's try this cone. All right, so volume of a cone is 1/3 capital B H, where the capital B stands for the area of the base. Well, in this example, this base is a circle. That's why it's called a cone, because the base is a circle. Well, that means capital B is the area of the circle, which is pi r squared. Well, what's nice about this one is the radius is given to us. The radius is 8, so this is just pi times 8. squared, and 8 times 8 is 64, so we're going to leave this as 64 pi. The height of this cone, remember that's the distance from the vertex straight to the base, straight to the circle, straight down perpendicular, and that height is 10. All right, now I can fill in what I know. 1/3 64 pi times 10. All right, so I'm going to go to my calculator. Remember, I'm going to leave this in terms of pi, so I'm not going to use the pi button. I'm just going to leave that alone. So if I go to my calculator, okay, so 1/3, move my cursor over, times 64 times, and the height on this one was 10 again, times 10. All right, so right now it's giving me 213.33333. I don't like decimals, so this part right next to it is a little circle with a fraction, so it tells me to put it in fraction form. And look at that. Fraction form is 640 over 3. So my volume is 640 pi over 3 units, which in this case was centimeters cubed. There's the volume of this cone. All right, again, what I would suggest is I would start reviewing these videos on finding the volume of pyramids and cones. I'll be giving a worksheet probably tomorrow on finding these, and then we'll have one more section, and then we'll get ready for a quiz for this stuff. All right. Hope everybody is doing well. I sure do miss you all. Bye bye.